Right, so I started recording. So, Jada, please don't mix up anti-clockwise and clockwise. Please don't do that. Right, please don't do that. So, Jada, I was saying that if you have a seesaw, right, this thing over here, this will be the pivot, and the pivot is the point about which something could rotate. So, Jada, if somebody sits on this side of the plank, wouldn't they generate a downwards force because of their mass? And that would cause the plank to move down like this? Yeah or no?
Yeah, it would.
It would. And because this person is sitting over there and the plank would now move in this direction, it kind of looks like it's moving in our direction, clockwise or anti-clockwise. Tell me, Jida, does that look like clockwise or anti-clockwise?
Anti-clockwise.
That's anti-clockwise. So you would say that this person generates an anti-clockwise moment. Okay, what if I put another fat person? We call this fat person Bob. I don't know any fat people named Bob.
One of my uncle.
Say that again.
One of my uncle.
Oh, okay. Well, this is Bob, right? If Bob sits on the other end of the plank, again, they would generate a downwards force, and the plank would now want to go in this direction. So that looks like it's going in a what direction? Clockwise or anti-clockwise?
Clockwise.
Jiran, did I confuse you or you with me so far?
Hello?
Yeah, Jiran, are you confused or you understand what I'm saying so far?
I understand.
All right.
General understanding.
Jira, do you understand what I'm saying?
Yes, I do.
Nice. Now, Jira, if the plank is balanced, and you could agree that the downward forces would have to be equal to the upward forces so that they cancel off.
Correct.
Correct? And what's the only thing holding up this plank? Tell me, Jira, what's the only thing holding up that plank?
The pivot.
The pivot. So the pivot would actually generate an upwards force whose magnitude is the sum of these two downward forces over here. So we could call this force F1, we could call this force F2, and you could call this the upward force. So we could probably call it F3. So if that is the case, right, Jada, and when I add up all the forces, I'm supposed to get 0
Correct.
because it balanced, right? Another way you could think about it is F3 would have to be equal to F1 plus F2. Now, Jaden, I hope I'm not confusing you, right? Here what I'm saying. I'm saying if this plank is balanced, it means that the net force is 0. No force is acting on it, so it's stationary. You understand?
Yes, sort of. Mhm.
Okay, Jaden, I'm gonna make it like this, right? So, Jaden, if you
Yeah.
want to hold up something, and you need to apply an equal force in the opposite direction to hold it up.
Yeah.
Yeah. So, Jaden, you can see that I have this fat person over here weighing down the plank.
Mhm.
I have this other fat person here weighing down the plank. So if I want to hold up the plank, and I would need to push upwards with this force plus this force. So I need to push upwards.
Yes.
You sure you understand?
Yes. I have a general understanding of it. I guess it's like the factor of seeing the weightings, but I'll pick it up as I go. If I have any problems, I'll tell you.
Okay, so Jaden, if you and your partner playing hand strength, right? And
Mm-hmm.
both all you have both all you have equal strength, all you exerting equal force. What's gonna happen?
Yeah.
What's gonna
You're
happen?
just gonna stay stationary, like you're not gonna
Exactly.
move.
Exactly. So Jaden, if I want this to be balanced, right? And I want the
Yeah.
forces acting on it to be 0,
Yeah.
I don't want our plank to go anywhere, right? So notice the kind of forces I have. I have downward forces and I have the pivot holding this whole thing up, so it has to exert an upwards force. So what I'm saying is this force over here has to be equal to the sum of these two forces.
Oh, okay. Yeah. I understand.
Mhm. Jida, tell me if you understand that.
Yes, I do.
Nice. So you would generally say for a system in equilibrium, you know how you had to use big words. And basically, equilibrium just means balanced. For a system in equilibrium. So if a system is in equilibrium, you need to know two things. You need to know that the sum of downward forces needs to be equal to what, Jada? What do you think?
Needs to be equal to the sum of upward forces.
Trust me, when you're doing aviation and you had to do like with vector analysis and the forces acting on the plane, oh good. You gotta real look at these forces. Good luck. You have it.
Thanks, sir.
You have it. So for us, a sum in equilibrium, the sum of downward forces is equal to the sum of upward forces. And we also need to take into consideration something else. So it have this thing called a moment. And a moment just so Yvonne, all a moment is, it's because of, so Yvonne, you're there, right? I just want to make sure you're there.
Yeah.
So Yvonne, and everybody on Earth have a mass.
Yeah.
And because of gravity, wouldn't they exert a force downwards?
Uh-huh.
Imagine your fat partner sit down there as a prank. You go dead, right?
Yeah.
Because he would exert a force on you, a downwards force. So because this person is exerting a downwards force some distance away from the pivot, it's going to cause a movement. That movement is called a moment. So you see how it's going to move in this manner? It called that a moment, right? So another thing you need to know, for a system to be in equilibrium, the anti-clockwise moments must be equal to the what do you think, Jaden? The anti-clockwise moments has to be equal to the what? See if you can figure it out.
Clockwise movements.
Oh yeah, Jada tell us. Jaden, do you understand why she's saying clockwise moments?
I guess to equal it out, like as how you were saying with the upwards force, maybe my assumption as okay, I don't know, like okay, I guess like how opposites attract, so you're trying to wanna like have the anti-clockwise and the clockwise be equal. That's my assumption of it. That's my take.
The first thing you said was correct, right? Jaden,
Mhm.
if I want this thing to be balanced, and I want all forces or all moments to cancel off, and they have to cancel off,
Yeah,
and you could understand that the anti-clockwise moments and the clockwise moments would be in opposite directions. Yeah.
yeah,
So if this thing is stationary, is it moving?
no,
No. So the movement should be zero. So in other words, this movement has to be equal to this movement because they're opposite. Tell me if you understand that.
yeah,
Great.
yeah.
So you've on the same page, right?
Mm-hmm.
Good. So let me just fix this up and you will copy this down. This is the basis for moments. Right? This is the basis of moments. So Jada, I feel like you like physics more than maths.
Yeah, the only thing I don't like is that physics contains maths.
I knew you was gonna say that, you know. I knew you was gonna say that. I knew you was gonna say that. Can I smell that coming from a mile away? Right? Principle of Jadon, do you know what a lever is?
A lever, like something you'd flick, like flick a switch, but like I guess in that sense, like you'd flick something with, in the sense of like turning something on and off.
Nah, that's not the kind of lever I'm talking about.
Oh well,
Okay, you know what's a crowbar?
crowbar.
Yeah, crowbar.
Yeah,
Okay, what about a screwdriver? Yeah, I don't know what a screwdriver.
yeah, yeah. Non screwdrivers.
Right. Do you think a screwdriver would be effective if if the length from the handle was short? You think that would be efficient?
Yeah, because there are screwdrivers like that.
No, it
So that's
wouldn't be
what's up.
efficient. If you notice
Really?
for heavy duty screwdrivers and it is normally thick and like very long. I'm trying to figure
Yeah.
out, I'm trying to figure out a common example that everybody would know about. Jada, and you know what's a crowbar, right?
Yeah, I do.
Yeah, Jada. And a crowbar would look something like that.
Yeah.
Now, let me ask you a question, Jada. You think with your raw strength, you could break open a door? You could break a lock?
Nope.
You sure you kind of strong, you know? I get the vibe that you're strong.
Maybe. It depends on the situation.
But you understand that if you have a
Yes.
crowbar, it would multiply the force you put in. Yeah?
Correct.
Correct. So, let me ask you a question, Jada. Do you think a long crowbar would be more efficient or a short crowbar? If you had to say.
A long crowbar.
Alone. Yeah.
A long crowbar. And why is that? Well, in this instance, wouldn't you apply a force over here and it would pivot about this point?
Yeah.
Yeah. I will show you guys the formula for moment just now, but it's going to make sense. I think all of us could agree that it have a lot of tools that allow us to do things that are quote unquote superhuman. So like Yvonne, you there, right?
Yeah.
Yvonne, you just help your dad out with like construction and thing? Like
Yeah.
stuff. Okay. But what easier? Okay, would you have to use more force for a small screwdriver or a big screwdriver?
A big screwdriver.
Nah, you'd actually have to use more force for a small screwdriver because it's
Okay.
it's closer to the screw. You could try it. Um,
And
okay, Yvonne, a crowbar. Do you think a long crowbar would be more efficient or a short crowbar? What do you think?
a long crowbar.
A long crowbar. So what I'm saying is, depending on the distance from the pivot, the moment is going to be greater. Let me give you an
Okay.
example of a seesaw, right? Let me give you an example of a seesaw. So, Jada, under regular circumstances, if you have a fat person on this side, right? Wait, let me give you a scenario. Let me just say you could sit wherever you want in this seesaw. So, Jada, let me just say this is you over here, and let me just say this is Bob over here. Bob kind of heavy. Now, some are like are they real young, right? Are they probably with a normal balancing skills? Are they normal balancing skills? Like you'd go in the clinic and they would have they'd have to like move the
The like little weights on the
yes,
long ruler looking thingy.
yes, that's
Have
so
I?
right. And then and it is move it until it becomes balanced. Yeah or no?
Yeah.
Right. So let me
Yeah.
explain that concept, right? Let me explain that concept. So Jira, under normal circumstances, do you think the seesaw would be in equilibrium here? Do you think it'd be in equilibrium?
No.
No. Yvonne, Jadon, do you think it would be in
Yeah.
equilibrium?
No.
No.
No. What if I take Bob and I bring him closer to the pivot?
Yeah.
What do you
Yeah.
think? Yeah, Jada, what do you think?
I think so as well. Yes.
But let me try to understand why. So the formula for moment, if you want to figure out the strength of the moment, you're going to use the formula moment is equal to force by the perpendicular distance from the pivot. So Jada, we can all agree that this is the pivot. And again, because we're on Earth and there's gravity and you have mass, it would exert a downwards force. So you would have some force. Um, let me just say you are weighing, I don't know. Let me just put 200 newtons for your weight. And let me just say that Bob has how fat do you think Bob is? Real fat. Like extra large. Shayna, give me a weight for Bob. How much newtons?
600 newtons.
Okay. So Bob is equivalent to 3 Jadas. Right. So Jada, just by looking at this, let me ask that question, Jada. Is the upward forces equal to the downward forces? To begin with, you don't even know what the upward force is, right? So you can't say anything about that. But Jada, if you're looking at the weights, are the weights equal? Tell me, Jada, are the weights equal?
No.
No, the weights are not equal. But if we look at the distance from the pivot, right? I want you to tell me who is further from the pivot. Are you further from the pivot or is Bob further from the pivot?
Yes, Jada is further.
Right, you are further from the pivot. And by you being further, it allows you to generate a greater moment than your weight would normally allow. Right? So let me show you how this would go, right? Let we actually try to find for something. So Jada, let's just say we don't know the distance you are from the pivot, and we could probably call that X, right? We don't know what it is. How far do you all think Bob is from the pivot? Give me a number. Give me it in meters. In physics, when we're talking about lengths have to be in meters. So give me a length.
5 meters.
I was saying like three or two.
Is that real long? Okay, I will use. Let me use 1 meter. I'll use 1 meter. I'll use 1 meter. Okay. So let me show you how this is gonna go, right? We first need to figure out what is the clockwise moment and what is the anti-clockwise moment. So we are going to take moments about this pivot over here. So Jada, if Jada is standing on this side of the plank, she generates a downward force, and think about how the plank would move if somebody pushes down and it's over there. It kind of looks like the plank is going in our direction.
And anti-clockwise.
Anti-clockwise. So this over here is an anti-clockwise moment. Jada, you agree with that?
Yes, I do.
All right. So this is an anti-clockwise moment over here. And Jada, because Bob is standing up over here and is generating a downwards force, imagine how the plank would look like if you push it on that side. It would start to move like this. It looks like clockwise or anti-clockwise.
Clockwise.
Right. So we have a clockwise moment over here. So if a system is in equilibrium, what did I say about the anti-clockwise moments and the clockwise moments? Somebody just remind me. Shayna, if we have a system that's in equilibrium, what do we know about the anti-clockwise moments and the clockwise moments? So Shayna, we did this over the holiday. Let me see if you remember. Let me see if you remember. Hmm. Shayna, Thomas. Let me see. Shayna, being awfully quiet.
Uh, that the clockwise moment equal the anti-clockwise moment.
Right. For a system in equilibrium, so it doesn't matter if you say anti-clockwise moments is equal to clockwise moments, or if you say clockwise moments is equal to anti-clockwise moments, it means the exact same thing, right? Right, so anti-clockwise moments is equal to clockwise moments. All right, so let's actually go over how you would find a moment. So to find the moment of something, right, to find the moment of something, you use this formula, force by perpendicular distance. So let's look at this formula a bit more in depth. So this is the formula for moment. Formula for moment. So F, so Yvonne, what do you think F stands for? F stands for what?
Force.
F stands for force, and force is measured in what? Do you remember?
Newtons.
Right, newtons. D, what do you think D is?
Down force.
Nah, D is distance from the pivot.
Alright.
Distance from pivot. So how far, in other words, is Jada or Bob from the pivot? Right, and what do I measure distance in? Shayna, what's the Oh, look, Yvonne already told me meters, right? Mm-hmm. And Sheena, moment. M stands for moment, right? Sheena, real quiet. These new
I'm
people
trying to, yes,
have you feeling nervous over?
slightly.
Sheena, these new people have you feeling nervous?
It's different, but it's fine.
Sheena, you was here before them, you know. You was the boss, right? Don't let them make you feel to be quiet. All right, and let me show you something interesting, right? So, Jada, you're seeing that moment is given by the product of force and distance, right? So, Jada, what's the unit for force again? What did I say it was?
Newtons.
And what did I say the unit for distance was?
Meters.
So, the unit for moment is Newton meters. Simple. That was easy, right? Tell me that was simple to figure out. Yeah or no?
Yes.
Okay, nice, nice. So, Jada, I want you to help me with the anti-clockwise moments because this is you. This is you over here. Let me just put names. This is Jada, and this is Fat Man Bob. So, Jada, let's try to calculate your moment. So, first things first, moment is equal to force by distance. So, Jada, what's your force? What's your force? By the way,
200
guys. Oh, yeah,
Newton.
weight is an example of a force. Some people just confuse weight and mass, but if you just confuse it, just remember. So Jada, and weight, this kind of sound like way down. Think about it.
Yeah.
And if you're
Does.
weighing down something and you're applying a downwards force to weigh something down,
Yes.
so weight is a force. Weight is actually measured in newtons, not kg, eh? Don't make that mistake. So Jada, your force is 200 newtons, and we have to multiply that by the distance. Jada, what's your distance from the pivot? Do we know where it is?
No.
Nah, we don't know what it is. I'm gonna call it X. I'm gonna ask somebody else now. So I see somebody here, Vani. Were you the person that just messaged me on WhatsApp?
I didn't hear you. Could you repeat?
You were the person that just messaged me on WhatsApp, right?
Yeah.
Okay, nice, nice. May I ask which past student? I'm curious. Which past students? Let's see if I remember them. Which
I'm really not hearing you, but that's clear. So you gotta kind of repeat. Sorry.
okay, I kinda curious. Which past student did you hear about me from? I'm curious.
So my mother asked her friend, and she son take class from you. So she kind of gives the number to her.
Oh, okay, cool. All right. Vani, did you do principal moments yet in school?
Yeah.
Yeah. Okay, so I'm gonna ask you to help me here. I'm put you on the spot. So if you want to find the clockwise moment, we need to multiply the object that's generating the clockwise moment. So in this case, Vani, who is generating the clockwise moment? Is it Jada or is it Fat Man Bob?
Batman ball.
Fat Man Bob. Bob is the man. So we're gonna multiply his force. His force is, what is his force? What's the force he's generating downwards?
600 Newton.
Right? What's his distance from the pivot?
1 meter.
Right, 1 meter. So I'm going to multiply 200 by x. So that's going to be 200x. And I'm going to multiply 600 by 1. All right. So Jira, let me see if you remember the algebra. So Jira, if I have 200 x's, I don't actually, I'll be crazy. And I want to find for 1x, what do I have to do? Tell me, Jira, I have 200x. I want to find for 1.
Divide.
I would have to divide both sides by. Think about it. What would I have to divide by 200 to cancel off with 200?
200.
Yeah. Guys, tell me if I blow up the planet or that making sense. That making sense? Trying to find for 1x. So I just divide by 200. Jadon, and 1 into 1 is 2. What's saying? And then 200 into 200 is 1. Tell me, Jadon.
Yeah.
Right. And whatever you do on one side, you need to do it on the other side. So, Jadon, some mental maths here. How much times 200 could go into 600?
3 times.
3 times. And remember, we were trying to find for x. X was our what? Was it our force? Was it our distance? What was it?
I believe it was the distance. Yeah, the distance between Jada and the pivot.
So what's the units I'm going to put there?
3 meters. That'll be 3 meters.
Right. Do you think you could get the marks for that in the exam?
Yeah. Once
think
you put your work
think
in
you
and
could,
stuff. Mhm.
right? Yvonne, what do you think? You think you could get our marks?
Yes, sir.
Yeah, I think so too. So I'll give you all some time to copy this down. Right, so first copy down this diagram. And if you want to send me diagrams and thing, say no more. I'll post it up on my story and big up all you. Maybe all your parents might see it and decide to buy all your doubles or something. All right. This- Jira, do you know what the other name for pivot is? That's F. F. Tell me, Jira, do you know what the other word for pivot is?
Is it like point or something?
Nah, it starts with F. No. Man said frequency. That's not it. Jadon, do you know? What's another word for pivot?
I am not sure.
Okay, I can try. Play some hangman here. So we're gonna hang Fat Man Bob. Right? We're gonna hang him. So the first word is F, right? And the end in an M. Jadon, when you eat food, you just feel what? When you eat plenty food, you just feel what?
Full?
Full.
Yeah.
And if something tastes good, would you leave no crumb? Would you leave any crumbs?
Nah.
Nah. So full crumb.
That's
That's the word. That's the
that's
word.
weird.
The word is fulcrum. I never heard the word fulcrum before.
No.
Technically, my physics teacher didn't teach me well because I never heard that in physics before.
I
Wait,
heard that word in physics before.
that's good. That's good. Right? So another word for the pivot is the fulcrum. So if you see it, don't get scared. Just imagine KFC. Because you're eating the belly full and you're leaving no crumbs. Yeah. All right. So as soon as I have the diagram copied down, let me know. Right? And I'll move on to the example so you all can copy that down. So Jada, when you look at complicated systems, do you think there'd only be one pivot or there could be multiple pivots? Tell me, Jada. So a pivot is if you think of a pivot as an object that holds something up. So Jada, do you think it is only have one pivot in systems or more than one pivot? Tell me.
I think it could have more than one.
Yeah, it could. And did you know that an example of a pivot is a wheel? Do you know that?
No, I didn't.
Think about it, Jada, and the motorcycle and the motorcycle riders, right? And they must be doing something like the one wheel go be on the ground and the rest of the thing go be up in the sky, yeah?
Right.
And they could pivot about this tire Tell me if I'm making sense.
Yeah, they
Yeah.
yes.
Yeah, they could. They could. So a wheel is an example of a pivot. A pivot is just a point about which you could make a rotation. That's all.
So if I'm not wrong, that is called this neutral equilibrium, no?
Yeah, this is neutral equilibrium.
Right. I remember something.
Yeah. Big up you, big up you. It have three types of equilibrium: stable, unstable, and neutral. I wouldn't call this stable equilibrium. It is balanced, right? But if it's stable, then it would be very stable. Jedi, understand that if you move in the previous example, if you move a little bit, Bob might overpower you with his weight.
Yeah.
Not a very stable. If I was making a TikTok video, I'd be like, tag somebody who in an unstable relationship. I would do that. Make a video. All right, so Shayna, as soon as you have everything copied down, let me know, right? Vani,
I would.
well, of course, use Flash, use Turbo. You just copy things down real fast. And I mean, you had these notes from the holidays too, so yeah, you could just rock back, right? All right, Jadon, you have everything copied down?
Yeah, and all right in the sum of downward forces. So,
Okay. All right, Jada, what about you?
Same as Jaden.
Okay, Jadon. Jada, I'm not gonna lie. When Jaden joined class, I said Jada. I said that.
I heard it, but I didn't say anything.
Yeah, because like the only thing different with their name is the two letters. So I didn't see a full name because I was sorting out something on my laptop. I just saw Gayd. Thought that was Jada. Because I didn't know your name, I remember I don't know your name. Jaden. I know I know your name is Jaden, but I didn't know that before.
Mm.
I just know Jaden.
Oh, yeah. My bad.
Yvonne, big up you. That is performance. I like that. Yvonne, boy, you draw them men with only belly. Belly making up 90% of them. I hardly see any leg, boy. All right, so Vani, are you taking our notes?
Yeah, almost done.
Okay, great.
So like rain falling by anybody else?
Nah, not by me. I up north side
No.
right now.
It have real thunder wherever I am.
Sun's stinging up
And
there.
this place so hot.
Sun's stinging there.
Okay, we gotta figure out where everybody is though. Jada, where are you right now?
In the bush called Mayaro.
Oh, are you from Mayaro?
You know me so long and you know me and I from
I
Mayaro.
know that. I know that. Why know that? I didn't know that. The other day I see a post of something about Mayaro girl or something.
Yeah. So good.
You know you're from Mayaro. Yeah. Well, I originally from DB, but right now I'm around with Sunrail hot over here. Jaden, where are you from? I'm curious.
I'm a mover. I'm like a chicken. I'm originally from Freeport, but I'm in Londonville by my grandparents right now.
Okay. Is it sunny or rainy over there?
It is hot as fire. Yeah, it's really hot.
It's hot like a sukuni.
I can see clouds. Yeah, I can see clouds, but the place still hot.
Okay. Well, hopefully some rain bless you just now. Yvonne,
Please.
Yeah,
what's the weather like by you? Ain't you from DB as well?
red hot.
Wait, boy. Shina, what about you? Rain or sun?
Thompson.
Sun? Wait. And Shina, where are you from? Which area?
Like Sparia.
Siparia? Okay.
Yes.
And Vani, rain or sun?
Like it's cloudy, but it has sun.
Wait, boy. Well, I hope I had rain Muslim. Yeah. All right. So,
So you can just scroll down because like
that good? Did everybody finish copy down this part? Let me know. Vani, did you
the
finish?
Zoom bar, yeah, it was kind of blocking the second one.
Okay. Are you seeing everything?
Yeah, I got it.
Okay, cool. All right, so I'm gonna move on. All right. If you didn't copy down anything, send any notes so it'll be there, right? So copy down the example now. So the point of this example was to find Jada's distance from the pivot. That was the point, right? And Jada, what do you notice? So Jada, in the diagram, who weighs more? In this diagram, who weighs more?
Fat man Bob.
Obviously, in the name, right? Now, to counteract for that, you had to do what? Notice Bob is 1 meter away from the pivot. How far are you from the pivot?
3 meters, so further away from Bob.
Right, to generate a greater moment. And you notice if you multiply 2 by 3 and to get back 600,
Yeah.
yeah, everything just makes sense. Everything just makes sense. So, Vani, I have a question to ask you, right? If you are close to the pivot, is your moment going to be great? Tell me, Vani, do you know? If you're very close to the pivot, is your moment going to be large?
Yes.
Nah. Vani, in this diagram, right? Who weighs more?
Batman Bob.
Right. He's weighing how much times more than Jada? Jada is 200 newtons.
400.
Now I wanted multiplication, right? So 3 times. 3 times, right?
Yeah.
Now, Vani, under normal circumstances, if you put Fat Man Bob and Jada on a seesaw, and Jada gonna fly up in the sky and see Jesus Christ?
Yeah.
Yeah, she gonna fly up in the sky. But by Fat Man Bob moving closer to the pivot and Jada moving further away from the pivot, you notice that the seesaw is now what? It's now what? So that's B. B.
B.
Yeah,
Balance.
balanced. Right. So Vani, to cater for the fact that they're different, that they weigh different weights, Jada has to go further away from the pivot. So Vani, we found that Jada has to go how much away from the pivot? How far is she from the pivot?
3 meters.
And how far is Bob from the pivot?
1 meter.
So Vani, correct yourself now. If you're light and you want to generate a greater moment, would you have to go closer to the pivot or further away from the pivot?
Further away.
Right. The closer you go to the pivot, your moment is going to decrease. And Vani, if you are on the pivot itself, what do you think your moment is going to be? So this is an interesting question to think about. So Vani, moment is equal to force by the distance from the pivot. So Vani, if you are on the pivot itself, what's your distance from the pivot? If you're on the pivot itself, what's your distance from the pivot?
But you're on the pivot, so like I don't know the distance. They could be the same.
Nah, here what I'm saying, right? If you're on something, then you're not any. I'm trying to figure it out. I'm trying to tell you it in a way that will make sense. Let me lead up to it, right? So, Vani, this is 1 meter away from the pivot. This would be half a meter. This would be a quarter of a meter. So if eventually you're on the pivot, what's the distance away from the pivot? If you eventually reach it, do you have any?
0.
0, right? The 0, because you're on the pivot. And if it's 0, and you were to find the moment, remember, moment is forced by distance, right? So if your distance from the pivot is 0, what's f by 0?
0.
So if you're on the pivot, your moment is going to be
0.
right. So the further away you go from the pivot, the greater the moment generated will be. Just please remember that. Right, so as soon as you all have this copy down, let me know. I'll give you all a question. Are you want me to troll into the ocean or do like a semi-easy question? Let me hear. Everybody real quiet. I don't know what to take.
Semi-easy looking, sir. Yeah.
Semi-easy, okay.
Yeah.
So I give me only 3 minutes to copy this down so I could move on. Should take 3 minutes and 30 seconds. Right. So when you are finished with the diagram, I'd like you to send me a picture of it so I could verify that you're doing everything correct. For some reason, some students would see what I have on the board and copy down something different. I'm not sure why. So just send me what you have when you're done. So Yvonne, let me check what you have here. Right, and Yvonne, if you want, you could draw a line through 200 and the 200, right, to show that it's canceling off, right, Yvonne?
Yeah.
But good job. Right, that's good. All right, so I'm waiting on the rest of you guys. So Jada, I want to see how you draw it. You said you can't draw, so I want to see. All right, Sheena, I'm looking forward to your diagrams. It's always look neat. Jada, I don't know I don't even know what your handwriting does look like. So send it. See what you do. Okay, Jada, let me see what you have here.
Before you tell me anything, I realize that I missed out damn part of the work.
Okay, that's good. You're supposed to put x is equal to 3 meters. And you're supposed to show the parts we're dividing. And another thing, notice that I have anti-clockwise moment as a curved path. Jada, let me ask you a question. If something rotated, would it rotate in an angular path, or would it just be like a smooth, like if something is rotating, right? And it would eventually carve the part of a circle if something is rotating.
Yes, it will.
Yeah. So change our anti-clockwise arrow to like a smooth curve. Jada, since when you're bald, I see that in the diagram you didn't draw no hair or nothing. Everything okay?
We'll keep that story for another day.
Okay. All right. Jaden, I'm waiting on your diagram. Right, Vani, yours, and Shina, yours. So for those that are done, let me just give you all a question quickly, right? I'm gonna stop share real quick. I will share the screen just now. Give me a second. I'm just getting a question for you all. So you all ask for moderately, like in the middle. So I'm gonna give all you in the middle, right? I just warning you guys, algebra alert, right? But Jada, you did say it was good in algebra, so this should be cake, right? All right. Give me a moment. All right, so I think you want to see the question first before you tell me how much time to give all you. Well, I want to see the question first.
Yeah.
Yeah.
I like that. You gotta be cautious. Can't take no chances. Sheena, I didn't get anything from you as yet.
Also, it's because I'm not plugging my phone to charge when you ask me that.
Boy, how come your phone always dead? I find that kind of sus, you
So
know.
my phone always dying. It's a constant thing.
Your phone sounding like me. Always dead. Um, well, when you have class, please make sure you connected to our charger, because I need to see what you're doing. Right, so this is the question. So, Jada, what do we think? Looking all overwhelming.
Kinda, but I don't think it's that complicated.
It is essentially what you would have done so far is just that in this diagram, you might have multiple clockwise moments and you might have multiple anti-clockwise moments. So this is what you're going to do. You're first going to recognize the clockwise and the anti-clockwise moments. It looked like in this diagram, yeah, you have a good couple. So if you have multiple clockwise moments, you're going to add them together and put that equal to the anti-clockwise moments and they're gonna add the anti-clockwise moments. So my first piece of advice is figure out what's anti-clockwise and figure out what's clockwise. So how much time will you think I'll need for this question? How much time?
If I begin real, sir, I
Yeah.
sort of kind of lost.
You sort of kind of lost.
I sort of kind of lost.
Okay,
I'd say
I like the honesty. Do you think you'd be able to figure out the clockwise and the anti-clockwise moments? Tell me that, Jaden. Jaden, tell me if you'd be able to figure that out.
I could try, yeah.
Okay, well,
Try to.
well, hear what? For those that want to try it by themselves, take a screenshot and load on your volume or something and try to do it by yourself. All right, do that. So I'm giving all 5 seconds to take a screenshot. 5, 4, 3, 2, 1. Okay, that's enough time. So, Jadon, let's start labeling. So, Jadon, this is the pivot, right? This is the point about which the plank could rotate. Yeah?
Yeah.
Okay, cool. If you have a downwards force over here, think about how the plank would move. If you push down on the plank over there, wouldn't the plank start to move like this?
Mm-hmm.
That's clockwise or anti-clockwise?
That is anti-clockwise.
Right. So this is going to be an anti-clockwise moment. Okay. So Jadon, this is the part that kind of confusing here. You never see an upward force before, right? Kind of weird.
Yeah. I guess it's like what? No, it's not really that. No. What's confusing me, I guess, is the jumble of meters in between the pivots and away from the upward force as well. I don't know if it's how it's like labeled, I guess.
I see, I see. Well, don't worry. It'll be fine. Trust me, it'll be fine, right? Okay. So Jadon, again, this is the pivot, right? And this is the plank. Imagine that you pull upwards. How will the plank, what position will the plank want to go? Would the plank look like this? Or would the plank start to look like this? If I pull upwards, would it look like 1 or 2?
From well, it would look like 2.
It would look like 2, right? Let me just say that one more time. So Jadon, this is the pivot here. I'm pulling from this side. So wouldn't it kind of lift the plank upwards like that?
Yeah.
So it kind of looks like a what kind of movement? Clockwise or anti-clockwise?
Clockwise.
Right. So this over here is a clockwise movement. All right. So Jadon, you're with me so far, like nothing confusing here, right?
No.
Good. Now let's look at the other side of the pivot. The other side of the pivot. If you push downwards here, if you push downwards, the pivot, the plank is gonna want to go in that position. So that kind of looks like a clockwise or anti-clockwise movement.
Clockwise.
That's a clockwise, right? And you think the 7 newtons will be what as well?
That would be a close moment as well.
Right, because it's the same thing more or less, right? It come like you're pushing down on it. So again, it would go in this position, and that kind of looks like it's going in a clockwise direction. Yeah. So this is clockwise as well. So Jadon, you're with me 100% so far, right?
Yes.
Nice. Let me find out from everybody else. Yvonne, look at what I do over here. Is it, did I do anything that was scary?
Nah.
Nah? Okay.
Yeah.
Jada, did I do anything that was scary yet?
No.
No? Vani, did I do anything that was scary?
Nope.
Nope? Okay, good. Okay, cool. So let's move on, right? So guys, if a system is in equilibrium, what do we know? What do we know about the moments?
It balanced.
Right. So what does that mean? What do we know? What does that mean, right? It means that the anticlockwise moment is equal to what?
Clockwise.
Right? Anticlockwise moments is equal to clockwise moments. Right, so Jadon, you with me so far?
Yeah.
Okay, cool. So remind me, what's the formula for moment? M is equal to?
Force by distance.
Force by distance.
Not just any distance, right, Vani? You think you could remember what distance? Is the distance away from the what?
Fulcrum?
Right, from the fulcrum or the pivot. Right? So let's find the anticlockwise moment first. Guys, how much anticlockwise moments do we have?
1.
One anticlockwise moment. So that's just going to be F by D, right? Okay. First things first, do we even have a force for this?
No.
No, we don't have a force, so that kind of scary. And Jada, we don't even have a force for this. We don't have a weight. I mean, we don't have a force, which is the weight, and that would be easier than because okay, this question really easy then. You could use it in two ways. All right. So Jaden, you're seeing that in the diagram, you don't have the force, right? You don't have the force. Seeing that.
Yeah.
Do we know its distance away from the pivot though? How far is that force from the pivot?
0.8 meters.
Nah. If this is the
Oh.
force over here, right?
Oh, so 2.2.
2.2. Okay. So we don't know what the force is, so we're gonna call the force X, right? So I'm going to say, and again, tell me if I'm losing you. I'm gonna call the force X, and I'm going to multiply that by its distance from the pivot. It's 2.2 meters from the pivot. Did I confuse you?
No. Well, okay. I guess what I mixed up before is how I mixed up upward force, which was these I can't remember how much newtons. I think it was like 25 newtons, the one that was going up. Yeah, I guess I mixed up that with the downwards. The metric I got for now.
I see.
Like that's what. Okay, yeah.
So you understand that I could just write that as X by 2.2, right? Yeah. X by
Yeah.
2.2. Cool. All right, let's look at the clockwise moments now. So Jadon, let's consider the 25 newtons first. So the force is 25 newtons and it's what distance away from the pivot?
0.8 meters.
Right. All right, so here what? Vani, I want you to help me now, right? So I don't just have one clockwise moment. I have multiple clockwise moments. So I'm going to say plus, and I'm going to add on the other clockwise moment. So Vani, which other clockwise moment you want to look at?
I have the 7
All right, we
and
could
the
do
20.
7. We could do the 7. So the force is 7 newtons, and what is its distance from the pivot? So if this is a force over here, how far is it from the pivot?
2.0 m.
Right, so 7 by 2. Right, and I also have to add on the 20 newtons, right? So that's going to be 20. 20 by what, Jada? How far is this force from the pivot? Come on, Jada.
1.3
1.3.
meters.
So I think you guys could handle it from here.
Yes, sir.
Yeah. So Jadon, everything makes sense?
Yeah. Yeah.
And I will show you another way to do the question when we finish. Right? It should work. So I'll give it only 3 minutes to solve it, right? Take 3 minutes to solve this. From here, it's just regular maths. All right. Vani, how are things going?
Almost done.
Okay. Shayna, I see that your internet giving a little bit of trouble. Let me know if you're there.
Yeah, so it keeps on like it fluctuating. But if it like disconnect, I'll be back after like 2 seconds. I don't know.
All right. Yeah, attempt any question?
So yes, but we did this already. Like I did this with you.
This exact
Invitation.
same question?
I'm pretty yes.
Okay, check to make sure it's the exact same question.
Yes, it is.
Okay, hold it.
Yes.
All right. Let me get you a question to do, right? So you can have fun with this question while you wait. You know, you're gonna do the question with the Chinese girl. You can take a screenshot of this fast. Right, you have the screenshot? Let me know. Shayna?
Yes, I have it. Thank you.
All right, take a screenshot of this as well. Right, I'm gonna assume you have it.
Yes, thank you.
All right, cool. Have fun with that. Good luck. All right. So I'm expecting to get some answers now. The time is up. All right, the time is up. Could somebody call out the answer? What did you all get for X?
60 newtons.
All right, we go see, right? Anybody else got that? Jada, did you complete the question? Can I hear from Jada? Vani, did you complete the question?
I got 60 newtons.
All right, Jada, what about you? Were you able to complete it?
So I'm almost finished. I'm almost finished.
Let me pull up my Casio calculator here. Jada, and I hearing you. Did you get through
Yeah,
it?
I got 60 as well.
Okay, cool. Right, so Jadon, let's do the question together, right? So Jadon, what's x by 2 by 2? I could write that as what? What can I write that as?
2.2x.
Right, 2.2x. Do I have any unknowns on this side, or is it just numbers?
It's numbers.
Just numbers, right? So I could plug that whole thing into my calculator. So 25 by 0.8, right? Plus 7 by 2 plus 20 by 1.3, close bracket. I'm getting 60. So 2.2x is equal to 60. Now, you guys were telling me that this is the answer. There's more working to be done though, right? So Jadon, I'm trying to find for 1x. So what would I have to do on both sides?
You'd have to carry across 2.2 and divide, well, 60 divided by 2.2, and you get the answer for x.
Correct. So you could think of it like you're moving
So
across,
it would be x equals to,
right? So you could think of it in two ways. You could think of it as you're dividing both sides by 2.2. And if you do that, the 2.2 and the 2.2 would cancel off to give you 1x. Or you could just think of it like this. You know, you're moving across 2.2. It was being multiplied by the x. So when you move it across, it's going to turn to division. So x is going to be equal to 60 over 2.2. 60 divided by 2.2. Let me just verify that. 60. So that's the actual answer. Jada, I guess we did not get that.
Asanya, Wadu?
Let me see what you do. Oh, I thought it said 60. That's correct. 27.27 newtons. Right? 27.27 newtons to 2 decimal places. A lot of you guys told me 60 when I asked for the answer. How much of you all got 27.27? Did any of you guys get 27.27?
Me.
Okay. Yvonne, what gave you trouble? If anything gave you trouble, what gave you trouble?
Nothing in my trouble, so I just forget to divide it at the end.
Oh, well, Yvonne, what are we trying to find for? Are we trying to find for 2.2x or are we trying to find for x? That's the question.
And,
Trying to find for x. So,
yeah,
you had to divide both sides by 2.2. Or just simply move across the 2.2, which will turn to division. Right? So,
okay.
just finish up this question, not paying the correct answer. And we're going to move on to some things you need to know moving forward. And then we look at what happens when you have two pivots. Right? So, does everybody have the corrections and the correct answer? Let me know, guys. All right, you've won. Good job. So I like to see. Right. Excellent job there, you've won. So we're gonna move on, all right? All right, so these are some things you should note going forward. All right, number one. Shina, are you there?
Yes, sir.
Shina, sometimes they would give you the length in centimeters. In that instance, what would you have to do?
So sorry, repeat. What I ask?
I say sometimes the questions would give you the length in centimeters. In that case, what would you do?
Convert it to meters.
Right. So Jaden, Yvonne, Vani, Jada, all of you guys, sometimes in a question, they give you the length in centimeters, but in physics, we work with SI units, right? Standard units, and the standard unit for length is meters. So if the length is not given in meters, convert it. Don't forget that. So for instance, right, let's just look at an example. Let's just say they give you the distance for something to be, let's just say they give you the distance to be 40 centimeters. Jada, how would I convert that to meters?
Divided by 100.
Right. If I divide 40 by 100, that's going to be what?
0.4.
Right? So that'll be 0.4. Right. Now, this is very impractical, very, very impractical. But if they give you the distance as 1 kilometer, how would you convert that to meters?
Multiply by 1,000.
Right, so 1 by 1,000 is just what?
1,000.
Right. Nice. So you should know that before moving forward to any other questions. You should also know that sometimes they give you mass instead of weight. Right? Sometimes mass is given. All right. So Shina, if mass is given instead of weight, we'll have to convert it. So remind me, Shina, what's the formula for weight? Is Shina in class? Oh no, the internet drop. Vani, do you know what the formula for weight is?
I forget to know.
What about force? Do you remember the formula for force? All right, that's okay, Vani. Weight is equal to what?
Newton.
Weight is equal to mass times gravity. That's what weight is. You can't forget that. You cannot forget that, right? Typically, the gravity on Earth would be 10 ms minus 2, or sometimes it would be 9.81. They would specify it in the question. So let me give you an example. Let's just say they gave you a question and they said that the right, they said that the mass was equal to, let me just say 10 kg. How would we find the weight? Yvonne here typing. I hope you're not typing in ChatGPT.
Oh, my mic unmuted. My bad. I
Yeah,
was writing.
that's all like typing. I catch you lacking there.
Nah, I was actually writing.
Okay. Right, so M is equal to 10 kg. So, Jadon, if I wanted to convert a mass of 10 kg to weight, if I wanted to find the weight for that, how would I do that? And I told you to use GS10. Use GS10. Do you know how you would do that? Tell me, Jadon. Don't be ashamed. Yeah, no, maybe. Don't be scared. Oh.
No, I'm not really sure.
All right, Jadon. So the formula for weight is mass times gravity. So what's the mass here, Jadon? What's the mass?
10 kg.
Right, so we're going to say 10 kg, and we're going to multiply it by g. What am I saying g is?
Well, 10 ms. So
Minus 2, right?
10 minus 3.
So what's 10 by 10?
10 by 10, that is 1000.
Yeah, 10 by 10 is not 1,000. I wish it was. I'd be rich. But I don't, well, 10 by 10 is 100, right? So the weight is 100 newtons there. Let me know if you understand that.
Yeah, I understand.
So sometimes in the question, they wouldn't give you the weight. You'd actually have to find for it. Just remember that, right? Oh, and I should just correct something one time, right? When you're doing moments, it's not given by capital M. In physics, everything matters. It really is supposed to be capital M, right? So just make that change one time. In the formula, it's supposed to be capital M is equal to force by distance. Just make that change, right? Please make that change. Capital M is equal to F by D, right? Guys, Vani, Yvonne, Jada, capital M, right? Not common M. Common M is used to denote mass. I use capital M. My bad. Right, so capital M is equal to F by D. Let me just make that correction here as well. Right, so I'll send the notes immediately after class. Right. So it's capital M is equal to F by D, right? So you all could copy this down. There's one other thing you need to know. Right? So there's one other thing you need to know. And then we can move on to some harder examples. Vani, you there?
Yeah.
Did you just not follow me on TikTok? I see somebody named Vani follow me on TikTok just now.
I didn't know you was on TikTok, honestly.
Oh. But that was you that followed me just now?
No.
Okay. Because somebody named Vani just followed me. The TikTok is the place to be. I have a real thing on TikTok. I want to, I nearly at 10K. I'm approaching it. Slowly but surely.
I'll follow you after class.
Okay, no problem.
Trust it before you reach.
What's that again, Jillian?
I say trust before the year up you reach.
Yeah, I gotta reach the 10K. I reached that. You see, the thing is, I finished on my bachelor's and I know in my studio home. So I can't really make the videos I would want to make. So kinda limited, but I would try to, because I just post high quality content and that's take real long to make. So I don't know if I'm gonna find time to do all that. I'll get through though. I will figure out something. All right. So as soon as you have this copy down, let me know. And if all you want, all you could draw the angry dog here. So you don't forget to convert it. Yeah. All right, Yvonne. I'll look it. I feel like you could draw in or Yvonne. It is giddy
You
vibe.
like it, bro?
So if you want to get draw the dog, I'll send my picture. Yeah. All right. Does everybody have what's on the screen? Let me know, guys. Let me know. Jada, do you have everything copied down on the screen?
Yes, I do.
All right. Jada, what about you?
Yes, sir. Just writing down the second example.
Okay. Yvonne, you have everything copied down?
Yeah. I
All
draw
right.
you dog again.
All right, good. Vani, are you drawing the dog as well?
I'm not that
Artistic.
artistic, so
All right. This dog here, this is Brownie. Everybody know a Brownie. And this is Brownie.
I have 4 dogs named Brownie.
What? So how you just differentiate between which one? How you just do that?
They have different spots on them.
So you call one caramel brownie, chocolate brownie.
No, all of them is Brownie, but they have weird names. Like, originally, they have weird names. So we just call all of them.
All of them brownie. All right, so guys, chop chop. By 10:30, I'm going to move on to the other thing you have to know. Right? Just 2 more minutes. Right, so 1 more minute to copy down everything. We're moving on. Hey boy, big up you. Yvonne, I'm gonna send me the any chat. This is art. This is to be celebrated. All right, let
When
me
I was in Form 1, sir, I got 100 and end up for art.
did not.
Yeah.
I will talk to him. I will find out if that's true. I know him personally.
Did they my
Responsible.
report, bro?
Eh?
Did they write in my report, bro?
Okay, good. I go ask him about you, see if he's give any trouble, then thing. All right. So let's move on to the next thing you need to know, right? So the next thing you need to know is that for a uniform plank, a uniform plank or body, the center of gravity right, acts directly All right, so Jaden, have you ever tried to balance your pencil on your finger?
Yes.
And you would have balanced it somewhere in like the center of the pencil.
Yeah.
So what I'm saying is, if you have a uniform plank or body, then the center of gravity would be in the center. And what's the center of gravity? This is the point in which all the weight of an object acts. So if you find the center of gravity for any object, you could hold it up in that one point because all the weight acts in that point. So Jadon, imagine I have a pencil, at the center of gravity, the whole weight of that pencil going to be acting downwards. So if you could support that exact point, it's going to stay in equilibrium. It's going to be balanced. Understand?
Yes, sir. Doing it right now, actually.
Okay, cool. So you're balancing a pencil?
Yeah.
Okay. Right, so copy this down and let me give you all a little diagram. Diagrams is the most important thing here. So if I were to have this uniform plank, then and if this plank was 1 meter long, then where do you all think the center of gravity would be? Jira, if it's a uniform plank, where do you think the center of gravity would act? Or where do you think it would be? If it's 1 meter long, if it's a meter rule, where would the center of gravity be? Tell me, Jira.
50 centimeters.
Right. So, like right here. Right? So this is the center of gravity. And in other words, the entire weight of the ruler will act at this point.
So in this case, right, can you also say 0.5 or no? You'd have to like change it to
Nah.
centimeters.
Actually, you should write, in physics, we only work with meters, right? So you should actually write 0.5 meters. It shouldn't say 50 centimeters. In physics, we work in meters. You need to say 0.5 meters, right?
Okay.
Right? And this point over here is the center of gravity. All the weight. Right, so copy this down and we officially in business, right? All I have to go through is 2 pivots and then we could look at the hard questions. And that's it. Finish something. That's it. We finish principle and moments. Guys, I don't know if I this older, but I remember Journey to the Center of the Earth. Jada, you had another movie. Jada, you had another one.
Yeah, I do.
Yes, sir.
Do you remember watching that one? Well, I grew up with Channel 9 and Channel 6 and thing. Jada, you grew up with Channel 9 and Channel 6 too?
Yes.
Nice. You called, yeah.
You know, I believe we are around the same age, you know, so
I believe so. I believe so. Yeah, yeah. So you remember, I think it was Channel 9, and every other night, I think it was Saturday night, they show a movie. Remember that? Was it Saturday night or Friday night?
I think it was Friday night. 1 or 32. I know what you're talking about.
It was Friday.
It was Friday. Yeah, I used to real be excited for that boy. Yeah, I went home all the thing was showing. But Jaden, how old are you by chance, if you don't mind me asking?
I'm 19.
Oh, 19, okay. So is it that you're writing back physics
Uh,
or you doing it privately?
where is this, sir? Yeah, very custom.
So are you doing physics privately or you're writing it back?
I'm doing it privately. This is my first time like doing it.
Oh, okay. I see. All right. Jada, if there's enough demand, I could have a Form 5 physics class. Yeah. Like with my schedule like insanely packed. Most of my classes finish 7 o'clock in the night. Like in UE. And then I come home. So
I
if you
finish work like 5 and I get home like 7, so it works for me. Anytime after 7.
okay. Well, how to do assignments something and so I gotta figure out a time. And the class might be 2 hours, it might be an hour and a half. Cause real things to do. All right, so as soon as you have this copy down, just tell me, right? And we'll move forward. Right, so Jaden, these classes are very interactive, eh? Like it's very, very interactive. I don't like silence.
Yeah, yes, I could tell by the questions.
Okay, that's good. Shayna, the Wi-Fi, that makes sense.
Not really,
No,
but I'm here for now, so I'm appreciating time.
okay, good. Did you try the tricky question I gave you?
Um, you see, the thing is, I started taking notes after a while, but I was kind of waiting for you to do two pivots because we didn't do it. We just did a bunch of like questions on one,
Okay, so
and then I'm going back to taking the notes from class, like we do now. So,
all right, so don't worry.
yeah.
After this, we're going to look at what happens when you have two pivots. All right.
All right.
So I'm going to move on now. Right? I feel like every minute I'm losing somebody and then somebody coming back. What is this boy? Where you van going? This internet is not it today. So let's look at what happens when you have two pivots. What happens when they are so if you see two pivots, are you going to jump off a bridge? I hear and
Wait, say
if you see two pivots, are you going to jump off a bridge? Are we going to jump off a bridge? Jida, are we going to jump off a bridge?
Maybe later.
Maybe later. No, don't say that. And so what happens when there are two pivots? So whenever you have two pivots, you consider one pivot and forget about the other one. So anytime you have more than one pivot, you pick one and take moments about that point. So, Vani, did you ever do two pivots before?
No.
Nah? Okay. All right, well, you're gonna see it today, right? Let me get some favorite colors, guys, so I can like incorporate it into the notes. My favorite color is blue. What about the rest of you
Blue.
guys?
Oh, my favorite color is blue too.
You know why, Yvonne?
Yeah,
What current what bill is blue?
100.
Oh yeah. Now, but ever since I was small, I like blue, right? What about the rest of you guys? What's your favorite color?
Green,
Green?
forest green to be specific.
Okay, okay. I guess I'm like not that like talking about like maybe like this.
Yeah, and
I just call that Baji green.
the RL. Yeah, I'll start calling it that from now on.
Baji green. Or if you want, you could say somebody breath. Because some people breath is be smelling real green. If you know, you know. Can't be me though.
So you have a smell, Mr. Rampol, bread?
Hey, I don't want to say anything, you know, like I'm post this on YouTube. I don't want to incriminate myself. Don't put me in no position there. Right. So let me show you how this does go. So Jada, in this diagram, how much pivots are you seeing?
2.
Two. Let's call this pivot A, and let's call this pivot B. So I coming up with these questions, so I hope it corrects. I coming up with this thing on the fly. So what if I put a force over here? Put a force over here. I could put a force of here. What? Let me not trust myself so much. Um, I'm going to get a question that has two pivots in it that would work out mathematically. Because if I come up with something, I need to. It's a long process. Let me just get a question with two pivots in it already. Two pivot questions. So you all could copy what I have on the screen so far. Wait, what is internet moving real slow, boy? It's like condensed milk. What the hell? Nah, boy. Things crazy, yes. Okay, give me a second. Video. Yeah. Okay, so this is a nice question we could look at. Give all this for homework. Okay, but is it the only question here? Yeah, that's weird. Somebody give me a random year. I'm going to search any physics past papers. Give me a random year, guys. Give me a random year.
2014.
2014. Let's see how lucky you are. Are there any? By the way, I think I could probably see how short a physics paper is be. It looking like plenty, but it's be real short. Like you could finish a physics paper in an hour and 30 minutes for the most. Right? Try your luck next time, Jada. Give me another paper. Pick another one.
2018.
2018. Okay. Let me check out 2018. Let me just see your luck. But they have like bad luck. I don't see any moments questions here. Let me check. Let me just run through this. Now I want to do a question with all that, so I don't want to do that question now. I'm looking for another question. So as you could probably guess, it don't really come that frequently. But you shouldn't count on that. The one time you think something not coming, it will come. Trust. Trust. As soon as you say nah, this not gonna come, it will come. But I feel I might really have to come up with that question at this rate. All right, here what? I'll do a previous question that I had, and we'll move forward. So let me get, I'm pretty sure I had one other than these. This question's so boring. Okay, here what Jada, we'll make up a question, right? So, because the question's way too easy there. I don't like that. Too easy. We need harder questions. We don't want peace, we want problems. Right? So Jada, give me a force. Give me a force over here. Give me a force. Any random force. But give me a force.
15.
15 newtons. Okay. How long will I want the ruler to be? Come on, guys. How long will I want the ruler to be? What's the length of the ruler? Give me a length.
20
20 what?
meters.
Right, you had to use meters, right? Okay, 20 meters. So if that's 20 meters, right? This force over here looking like how much are the 20? Like how far is
That
it?
would be like 5 or 4 or something.
Probably say like 5 meters, yeah. Okay. Um, how much are they want the plank to weigh? Because obviously the plank would have a mass, right? Actually, give me the mass in kg. Give me the mass in kg, right? So the plank has, let me just say that the plank has a mass of what? How much do I think this plank weighing? It's 20 meters long. It kind of sound big. Give my mass for the plank.
100 kg.
Okay. You giving Bob a run for his money, boy. This plank. Plank has a mass of 100 kg, right? And is uniform. Okay, so Jadon, you there?
Yes, sir.
Okay, so Jadon, I'm saying that the plank has a mass of 100 kg and is uniform. So let me see how good all is, right? Based on what I told you guys, you have to remember, if I'm saying that this plank is uniform, where would the weight act? So you'd have to find for weight as well, right? We should probably do that first. So if the plank has a mass of 100 kg, how could I find the weight of the plank? Just remind me. I'm going to call what for this boy? Vani. Vani, do you remember how to find for weight? Come on, do you know how to find for weight? Do you remember?
Mass by gravity.
So the mass here is 100 kg, and let's just say the gravity is 10. So the weight of this plank is going to be what? 100 by 10 is?
1,000.
So that's going to be 1,000 what? What is weight measured in? Weight. What is weight measured in, guys? Somebody remind me.
Newtons.
Newtons, right? Newtons. So based on what I told you all that you need to remember, where do you think that 1,000 newtons is going to act? Where is it going to act? Somebody tell me. So remember, I told you guys that a uniform plank or body, the center of gravity would act directly in the center. So guys, any question, are they saying that the plank is uniform? Somebody tell me. Yvonne, are they saying that the plank is uniform?
Yeah.
Yeah. So if the plank is uniform, where is all of its weight acting? What distance?
Directly in the center, which could be around 10 meters.
Right. Now, 1,000 newtons is a big force, so draw a big arrow for that. Okay. All right. Now, and let me just say it have a force over here. Let me just say this force over here is 200 newtons. Right? I promise it will all make sense very soon, I promise. All right. Jida, what distance would from here to here be? Do you know? Jida?
Like
No.
10.
It would exactly be 10, right? And what if I told you that from here to here, that probably looking like what? What, like 3 or 4? You could say like 3.5 meters. Okay. All right. And I could tell you that from here to here is 3. So Jada, things starting to look a little complicated, and a little complicated.
Slightly, not really.
A little bit. Not
Little bit,
not
right?
that much.
I promise, guys, it's the same concepts, just over and over. All right. So again, I'm coming up with this question, so let me just take a step back and make sure it's valid. Right. Okay, yeah, it's valid. Right. So Jada, if I have 2 pivots, don't those 2 pivots have to hold up that whole weight of the plank? Tell me if that makes sense.
Yeah.
Yeah. Right? So in this diagram, you have a plank and you have two things also on the plank. Let me just say you have something over here, right? On the plank over here, and you also have something over here. All right. So the question is to figure out the force over here, right? Jira, do you understand why I'm putting an upwards force by the pivots? Yeah or no? So this is where people will get very confused. Rightfully so. It's not the easiest thing. Could somebody tell me why I'm putting an upwards arrow by the pivot? Does anybody know? Does anybody know? Vani, do you know?
No.
Okay, Vani. The pivot, right? If I remove the pivots, would the plank be held up? Would it be held up? Like if I remove the plank, imagine you have a piece of wood here, right? And you have two planks. Vani, if I remove those planks, and the plank is gonna drop to the ground.
Yeah.
Yeah. So Vani, because the plank has a mass, wouldn't it generate a downward force?
Yes.
Mm-hmm. So if I want to keep that plank upwards, wouldn't these pivots need to be pushing this plank upwards to kind of cancel off the downwards force? And
Yeah.
I don't want you to just say yeah. If you don't understand it, tell me.
No, I understand.
All right. Jaden, you remember I was saying that, if you have a downwards force here, you would need upward forces to cancel off with that. So the net force would be zero. Remember I was saying that?
Yeah.
So you understand why the pivots would be, the forces at the pivots would be upward forces?
Yeah.
Because Jaden, if you think about it common sense wise, and the pivots holding up the plank, and they holding up the plank,
Yeah.
holding up. So the force has to be acting upwards. All right. Okay. So stay with my guys. I know it's looking a bit complicated. I get that. But all you seem like all you have potential, so pick up all yourself. Right? It's all right, so Jiran, remember what I told you? Wouldn't the pivots have to hold up the whole weight of everything? Wouldn't they have to hold up the weight?
Yeah. You heard me, sir.
I kinda heard you. I hear a lot of noise in the background.
That's the rain. Trying to reach.
That rain is very loud. Well, look rain busting right now. All right. So, Vani, let's try to analyze what we have here, right, Vani? So what I have here is a plank, and on the plank, you have two objects. You following?
Yeah.
So Vani, wouldn't the plank have a weight?
Yes.
Would the weight act upwards or downwards?
Upwards?
So Vani, if somebody sit on you, would they act upwards?
No, they would act downwards.
Right. So weight always acts what? Weight always acts what?
Downwards.
Right. So you understand that the weight of the plank is 1,000 newtons and it's acting downwards because it's weighing down it'll be acting downwards, right? Because of gravity. Yeah.
Yeah.
These objects over here, they would have a mass, and so they would also have a weight, and it would be acting downwards. Yeah.
Yeah.
Would this act upwards or downwards? The weight for that object there. Upwards or
Then
downwards, right? And so, Vani, and we would need something to hold up all of this weight.
yeah.
So in this diagram, what's holding up all the weight?
The two pivots.
The two pivots. Lovely. So do you understand why I'm drawing upward arrows for them?
Yes.
It's in the name, right? Holding up. Holding up. It's in the name. Sheena, let me know if you're confused or you understand what I'm saying so far.
No, so answer my thing.
Okay, great. Now, praying to God that this question is valid because, like I said, I come up with it. So, here what? The first thing I said was you're going to, anytime you have more than one pivot, you need to take moments about 1 point. 1 point. So, Jada, I want you to pick a pivot. Pick A or B. Which one? Pick one.
A.
A. All right. You're picking A. No problem. That's fine. So let me show you what's going to happen if we pick A. So this is the hardest it would come in CXC. Like I believe, hardest it would come. So Jada, if we are picking, you said A, right? We're picking A, right?
Yes.
Okay, cool. If we are picking A, then A is going to be the point at which the plank is going to rotate about. So I want you to forget that B existing, right? Forget that B existing. Just keep in mind that it would have an upwards force, right? So Jada, stay with me, right? If you start to feel lost, tell me. Tell me, right? I'm being very careful here because it's very easy to get lost. So Jada, we are picking A. So Jada, if we are picking A, you're gonna forget about this pivot here and you're gonna work with it like how you would normally do it. So first things first, Jada, if our system is in equilibrium, the anti-clockwise moment is equal to the
Clockwise moments.
right. So Vani, don't be ashamed. If you're starting to feel lost, tell me one time. One time. Don't be scared. Right? Sheena, you know how it is go. Yvonne? Yeah? Jaden? Cool.
Yeah.
Right. So Jada, let's figure out what's gonna happen. So like I said, is it come like what we was doing at the start of class. So if this is the pivot and you apply a downwards force, the pivot gonna want to slant in this direction like that. So that looking like a clockwise moment or anti-clockwise moment.
Anti-clockwise.
Right? So this over here, anti-clockwise. Fanny, confused or you understand?
I understand.
Right. Fanny, let me test you, right? This, since we are looking at A as the pivot, would this force generate a moment? It's at the pivot. So would that force generate a moment? If that force is at the pivot, would it generate a moment?
Yes.
Nah. So Vani, what's the formula for moment? M is equal to? Moment is equal to what?
Force by distance away from the pivot.
Right. So Vani, if we are at the pivot, right? And this force is at the pivot, what's the distance away from the pivot? It's at the pivot. What's the distance from the pivot if it's at the pivot?
0.
So wouldn't that be F by 0?
Yeah.
So would it generate a moment?
No.
No, because what's F by 0?
0.
So the moment at the pivot would be 0. Jadon, do you see what I'm talking about? This is important to understand. Do you see what I'm talking about? Right. Sheena, do you understand what I'm saying? I'm saying that if you are at the pivot, the force would not create a moment. Sheena, do you understand?
Yes, sir.
Right. So if you are at the pivot, M is equal to 0 because the distance from the pivot would be 0 as well. Cool. So we know that. So Jada, after I just told you that, right, Jada, are you going to bother with this? Are you going to bother with that force?
No.
No, because it's at A, right? And we're taking moments about A. So forget that. Forget that exists. So we have one anti-clockwise moment so far, and that's going to be, so it's force by distance. So the force is 15, and the distance is what?
5 meters.
5 meters. Okay. Let's look to see if we have any other anti-clockwise moments. So Jaden, actually, I have plenty written by you. I'm gonna ask Yvonne. Yvonne, you there, right?
Yes, sir.
So Yvonne, if this is the pivot, right? If that's the pivot,
Yeah.
then all the rotation is gonna happen about that point. So imagine you have a downwards force. That would cause the plank to be pushed down in this direction. So this starting to
Yeah.
look like a what? Clockwise or anti-clockwise?
Clockwise.
Right? This is clockwise. Oh my. Right. So this is clockwise. Okay. Vani, if this is the pivot, right? This is where all the rotation is going to happen about. So again, forget this pivot, right? Forget that pivot, yeah? Right, Vani? Forget that pivot.
Okay.
Right. But even though we're forgetting the pivot, we're still going to take into consideration its force. So Vani, that might sound a bit confusing. So Vani, and that pivot is a point about which something can rotate.
Yeah.
Right. So we are taking moments about A. But Vani, does that take away the fact that there's a force, an upwards force over here? If you look over here, and there's an upwards force,
Yes.
do we know what our upward force is?
No.
No. So we could call that upward force F. What is it?
Okay.
We could probably call it X, right? Let me do X, right? Yvonne, did I confuse you?
No, sir.
All right, so Yvonne, you understand that we dealing with this pivot, right? That is the only point where rotation is going to happen. But that doesn't take away the fact that you had an upwards force over here. And it still have an upward force over here?
Yeah.
Right. Do we know what the upward force is?
No.
No, so we call it X. Right? So let's work that out. If this is the pivot and you apply an upwards force, the plank will want to rotate in this direction. So what direction is that? Clockwise or anti-clockwise?
Anti-clockwise.
Right. So this would be an anti-clockwise moment over here. Is there anybody confused about that? Vani, be honest with me. Are you confused about why I'm saying this would be an anti-clockwise moment? Be honest with me.
No, I understand.
You understand? Jadon, do you actually understand? All right, Jadon. So Jadon, because I had a pivot here, it would have generated an upwards force. Now, Jadon, we're taking moments about A, right? We are. So the plank could only rotate about this point, but that doesn't take away the fact that we had an upwards force over here. So Jadon, if this is the pivot and you apply an upward force, it come like you're pulling the plank upwards in this direction. So Jadon, does that look like clockwise or anti-clockwise? Right. That's why I said that this was an anti-clockwise moment. So now we would need to figure that out, right? So, Vani, It's going to be force by distance. Do we know what the force is over here?
No.
Nah, so we're gonna call it x. Do we know its distance away from the pivot?
Yes.
Not quite. Were you gonna say it's 3?
Yeah.
What pivot are we dealing with in this diagram? Tamavani, what pivot are we dealing with?
Oh, okay, we dealing with E.
Right, so we need to figure out how far this is from A. That's the question. Understand?
Yeah.
So let me see if we could figure that out. All right. All right. So let me do some quick maths, right? So this thing over here, this would be 15. This would be 15 meters. All right, that's 15 meters. Right now, we're trying to figure out this distance over here. Trying to figure that out. So to figure that out, so Jada, let me see if you can figure it out, right? How would I figure out this distance? Think you could figure that out, Jada? Look at all the lengths you have here. Is it enough to figure out what this is?
I think so, yes.
Let me study it closely, right? Let me study it closely. Actually, this wouldn't be 15 meters exactly. It would not. This would need to be 5 meters over here for that to happen. So maybe I could say, you know what? Maybe I could say that this is 0.5 meters. All right, so Jada, if I say that this is 0.5 meters over here, and this is 5 meters, then what would the distance from here to the other end of the plank be? Think you could figure that out?
14.5.
Yes, that would be 14.5 meters. Excellent. Again, I cannot come up with this question, so it's kind of sketchy. The questions in CX will be easier. It's like real hard. Right? So, Jada, you understand that part, right?
Yes.
And we are trying to figure out the distance that this is from over here. Yeah?
Yes.
Right. Now, it would be possible if we took away this portion from the 14.5. Do we know what this length is? Somebody other than Jada, tell me, do we know what our length is?
That's 3.5.
3.5, correct. So you would have to take away 3.5 from 14.5. If you do that, what are you going to get?
11.5.
Right,
I mean 11.
11.
Yeah.
Now, I see how that would be very confusing. Vani, would you like me to run that back one more time?
No, I understand.
All right. So for anybody that's confused, here what going on, Here what going on. I added a new piece of information because we needed that new piece of information. I said that from here to here was 0.5, and from here to here is 5. So if this is 5.5, then the distance from here to here would just be 20 minus 5.5, right? Because this part of the plank would have been 5.5, so the other part needs to be 14.5 to give you back the 20, right? Now I'm trying to figure out the distance from here to here. Now I would get that distance if I take away something from this. So if I take away this length from the 14.5, that should leave me with this. And did I know what that length was? Yes, I did. It's 3.5. So 14.5 minus 3.5 is 11. China, are you confused?
No, sir.
No? Okay. So it's going to be x multiplied by what, guys? What's the distance from this force to the pivots?
11 meters.
11, right? Lovely. And that's going, wait, let me see if I have any more anti-clockwise movements, right? So, Yvonne, we handle this force, we handle this force, we handle this force. This is the only force remaining. So, Yvonne, tell me, if this is the pivot and I push down the plank in that direction, the plank would want to go in what direction? Clockwise or anti-clockwise?
Clockwise.
Right. Right. So, tell me, Yvonne, did we consider all the anti-clockwise moments?
Yeah.
Right. Let's look at the clockwise moments now. Right. So let's do that. So that's gonna be tricky again, right? So Yvonne, which clockwise moment you want to consider first?
15.
15 is our anti-clockwise moment.
200 and
200, okay, sure. So that's going to be 200 multiplied by the distance. Let me see how bad it is. Oh, how far is 200 newtons from A? See if you can figure that out.
14.5.
Nah,
Oh, wait, no. 14, no, that is 17.5.
nah.
Uh,
Check this, right? Check this out. If this is 11 meters
mhm,
and this is 3 meters, then the whole distance would be what?
14.
Yes. It's really 14. Right? Okay, cool. All right. Vani, I want you to help me figure out the other clockwise movement. So the other clockwise movement is over here, right? Yeah.
Yeah.
And we're trying to figure out how far it is from over here. That's what we're trying to do. So how far is it?
4.5?
You said 4.5?
Yeah.
You'd be correct. Big up you. Right? Jada, do you understand how she found that?
Yes.
All right, so Jada, explain. Pin you on the spot here. So first of all, Jada, that 1,000 newtons is located in the middle of the 20 meters, right? So from here to here is what? What's there to there, Jada?
10 meters.
Right? And this distance from here to here is what?
5.5.
Right? So the remainder is just going to be 4.5. Excellent job. Big up all yourself, all your smart. Right? So the last one is going to be 1,000 multiplied by what, guys? 1,000 by what? By 4.5, right? Cool. So what's 15 by 5? I need somebody on the calculator. 15 by 5, they're looking like 85. Is it? It's 15 by 5, 85. Say that again?
75.
Okay, yeah, because 5 by 5 is 25, right? Right,
Yeah.
75. Okay, this is going to be 11x. 200 by 14, that's going to be 2,800. And 1,000 by 4.5, that's going to be 4,500.
Yeah.
Let me just simplify the right-hand side first. So 2,800, that's going to be 7,300. I want to find for 1x. So, Jada, if I want to find for x, right, I want to isolate the x terms. So, you see 75? 75 shouldn't be there. So, I should probably move across 75. If I move across 75, I'm going to end up with 11x is equal to what? Tell me, Jada.
7,300 minus 75.
Right. And if you do that, it should get 7225. I'm doing this on my head, so you could just check it on your calculator.
Yes, sir, that's correct.
Right? And then if I want to find for 1x, you'd have to divide both sides by 11. If I do that, x is going to be what? I can't do this one in my head. I can't.
656.81.
656.81.
Yeah.
Right? And that'll be newtons, right?
82, sir.
You all getting that? Let me just
So it's
verify.
18.82.
7,
To see
2.
the smallest.
Somebody, Shina, was saying something?
It's 0.82 to the small pieces.
Right. Thank you. Okay. Okay. Cool. Now, that being said, what did we just now find for? That's my question. What did we just now find for? Let me look back at the original diagram. So guys, what did we just find for? We found x to be 656.82. What did we just now find for? Somebody tell me. What did we just find for? Fanny, do you know what we just found for?
X,
Right. And x was an upward force or a downward force?
upward.
Upward, right? Lovely. So if I recall what the original diagram was, we just now found for this force over here. So this force was 656.82 newtons. So Jada, was it really that hard? Was it anything that we didn't do?
No.
It's just like it looking scary, but it's not that deep. It's not that deep. Now, we not finished yet, right? Or they would probably realize that we still don't know what this force is until they see that. Do we know what this force is, Jada? Shina, you was answering. Tell me, Shina, do we know what our force is?
No, sir.
But Shina, this system is in what? What do we know about this system? This system is in what?
Equilibrium.
Right. So for a system in equilibrium, we know that the upward forces must be equal to the
Downward forces.
right. Now, if you could take, okay, so Yuvan, you saw how we took moments about A and we got for this? You found that?
Yeah.
If you took moments about B, you'd find for this. But we don't have all that time. We don't have all that time. So what we could do
Yeah.
is we could just say this system is in equilibrium. And if a system is in equilibrium, then just remind me, guys, the upward forces must be equal to the Fanny, tell me.
Downward forces.
Okay, Shana, yes. Nice. Upward forces equal to the downward forces. Right. So don't worry, guys. If anything confused you in this session, you can check back your recording, message me, or wait till the next class. I will go over everything that's confusing you. I don't want anybody to be lost. Because like physics is something, like if you don't say something and you just keep on getting lost, you're gonna be screwed. You're gonna die. Right? Alright, cool. So Jadon, are you there?
Yes, sir.
Right, so Jadon, remember I was telling you if our system is in equilibrium, the upward forces must be equal to the downward forces, right? So Jadon, we do all our work and we found for this upward force, yeah?
Yeah.
Right. What's the only force we're missing in this diagram? What's the only force we're missing?
the upward force on A.
Exactly. We want to call that. We want to call that. Come on, letter.
Um,
Already called this one X, so maybe I should use another letter.
Y.
Y?
Does it? Yeah.
Okay, cool. We could call that Y. And so if that is the case, right, Jaden, first of all, tell me what the upward forces are. So we're gonna add the upward forces. So Jaden, what are the upward forces in the diagram?
It would 656.82
Mhm. Plus what?
plus
Plus
Y. Yeah,
right?
Y.
Plus
Yeah.
Y. And that'll be equal to the downward forces. So Shayna, I want you to tell me what the downward forces are.
15,200.
Lovely. If you add up everything on the right hand side, you're supposed to get 1215. I think. Check that. Check that back. Somebody check that for me. All again,
Yes, sir.
cool. And to find for Y, you'd have to move across what, Jadon? Or would you have to move across?
You'd have to move across C 656.82. So that means it'll be 1,215 minus 658.82.
Right, and what are we gonna get for the answer?
558.18.
500 and what?
58.18.
Right. So guys, did we complete the entire diagram?
Yes.
Yes.
No.
Yeah, we did. Yeah.
Yeah, we did. Yeah.
This is the hardest it will ever come to see it. It doesn't get harder than this. The hardest thing that would come. This is like, it's like extreme, right? So Jaden, this was like extreme level. And you could have still kind of understand it, right? Did I lose you anywhere? Anywhere?
No, not really. Like the only part that you like, I was a bit lost was when you were adding in the other values, like the 0.5 and the 5 meters. But I understood it once you explained it.
Oh, okay. I just add the 0.5 because without that 0.5, I could not do anything else. I did that 0.5.
Yeah.
I just add that,
Mhm.
right? So yeah, that's that. So that is how you would handle a question like this. So I'm going to send 2 questions for homework. 2 questions. And yeah, you all could try it. So I'm just going to run through this question one more time. One more time, really fast. Right. So who wants to run through the question with me one last time? One last time. Any volunteers? I hear any crickets chirping in the background. The crickets chirping,
I'll
right?
do it.
You can do it?
Yes, sir.
Thank you for saving me. Right. So Sheena, in this question, how much if we look at the original question. So Sheena, if you look at this question, how much things we don't know?
We don't know. Okay. We don't know the force for A and B. We don't know the distance between the two pivots. That kind of thing.
Right? But the main thing we don't know, the main things that we don't know, right? We don't know what this is, and we don't know what this is. That's the main things we're interested in, right? Right, Sheena? It's the main
Oh,
thing.
yes, sir.
So here what? You decided to take moments about where?
A.
A. Now, before we move on, Shayna, I had told you that the plank had a mass of 100 kg and is uniform. If that is the case, where would all the weight act? If the plank is uniform, where would all the weight act? In the what?
I said,
In the center. Now, they gave us the mass of the plank, so we have to convert that to weight. So weight would be mass by gravity, which is 100 by 10. 100 is the mass and gravity is 10. So 1,000 newtons. So I trust that everybody okay up to this point. So the next thing we decided to do was take moments about A. So if we're taking moments about A, then the Planck could rotate about A. It could only rotate about A. Shayna, can you tell me why I'm not bothering with this force over here?
Because the force at the pivot would be 0.
Exactly. The not necessarily the
Moment.
force, the moment would be
No.
0. It could have a force, but it would just be 0. Because F by D, the distance is 0. It would just be 0. Right? So I think everybody understood why this was anti-clockwise. Because if you push it downwards, the pivot, I mean the Planck is gonna start to rotate in this direction, anti-clockwise. If this is the pivot and you pull the Planck downwards, it's gonna go in this position and it's gonna start to rotate in a clockwise direction. Yeah? And same thing for this one. Now, Shayna, can you explain this one quickly? Why am I saying this is an anti-clockwise moment?
Because if you push it, will go anti-clockwise.
Right. If I were to pull it upwards, it would go in an anti-clockwise direction. Right? Yeah. So you understand that?
Yes, sir.
Right. Let me just put something in bold here. Taking moments about E. That's what we did for this question. We took moments about E. So, Jadon, you feel like you understand why I say anti-clockwise, why I say clockwise, why I say anti-clockwise, and why I say clockwise, yeah?
Yeah.
Cool. So if we handling up the anti-clockwise moments, this was 15 newtons here, 15 newtons, and its distance from A was 5, so I say 15 by 5, right?
Yeah.
This was also an anti-clockwise moment. It was a distance. We didn't know what the distance was, right? But let me show you how we find that very fast. So we knew that from here to here would have been 5.5 because this was 0.5 and this was 5, right? So that's 5.5, right? That was 5.5. So if that is 5.5, then this entire thing here would have to be 14.5. That confusing you?
No, and that meaning like just to make up the 20.
Exactly,
Oh,
just to make up the 20, right?
yeah.
Just to make up the 20. And if we know that this distance in the middle is 3.5, then I would just take away 3.5 from 14.5 to get the 11. Bam, that's how we get the 11. Understand?
Yeah.
And then to 200 by 14. We dealing with this one, right? So we're looking at the 14.5, right? You're looking at the 14.5 here. And
Yeah.
okay, let me see what's going on there. Give me a second. So we said that that'll be 14. But why? Let me see. Let me run that back one more time. So from here to here is 14.5. We know that.
I think it's because of how you put the 3.5 and yeah, it intersects with take away the 0.5.
Correct. Because this will be 0.5 over here. This distance there will be 0.5. So 0.5 take away 14.5 is 14, right? So we understand this perfectly, right? And we understand
Yeah.
the 4.5 here as well, right? Because this would have been at the 10-meter mark from here, 10 meters. And we know that this is 5.5. Take away that from 10 and you get the 4.5 over here. So from that point, it's just algebra. And I trust that we're okay with the algebra, so we know how to get x. The last step was to say upward forces is equal to downward forces to find the other upward force by the other pivot. So does everybody understand the gist of the question?
Yes, sir.
Right. So how you guys feeling? We tackled that extremely difficult question at the CSEC level. How are you feeling? Let me get some feedback. Jada, how you feeling? Feeling like you can mash up CXC right now?
I feeling like I can mash up anything right now.
Whoa. Whoa.
Especially our maths homework.
Okay, that was good. Let me go. Right. Yvonne, how you feeling?
Feeling cool.
Cold?
Yeah, right.
But you understand everything, right?
Yeah.
When you say feeling cool, it's because of like you're feeling tough, you know everything.
Nah, actually it's freezing.
Oh, okay. Glad to hear you understand everything.
Yeah.
Val, did you understand everything we did today?
Yes.
Yeah? Nothing confused you, right?
No, there had times I was confused, but then like when you explain it, I understand.
Okay, good. So you're leaving class today unconfused, right? Like you're good.
Yes, I am good.
Cool. All right. Sheena, you're good?
Yes, sir. I understood everything.
Nice. So, guys, I hope all you have a blessed day. I'm going to send the notes immediately and the homework. I'm going to send 2 questions. So, yeah, guys, later, everybody, have a blessed day. Bye.
Just